Are we alone in the universe? This profound question has fascinated humanity for centuries. As we embark on a journey to uncover the truth about extraterrestrial life, we'll explore scientific evidence, real-life encounters, and the far-reaching implications of discovering life beyond Earth. The night sky, a canvas of countless stars, each potentially hosting planets teeming with life. The sheer number of planets in the universe suggests that it's statistically improbable for Earth to be the only cradle of life. But what kind of life might exist? And where could we find it? Our search begins with extremophiles, organisms that thrive in conditions once thought uninhabitable. These hardy creatures are found in Earth's most extreme environments, from deep-sea hydrothermal vents to acidic hot springs. For example, the tardigrade, a microscopic water-dwelling animal, can survive in the vacuum of space, extreme radiation, and intense pressure. If life can thrive in such conditions on Earth, could similar organisms exist on other planets or moons? Mars, the red planet, has long been a focal point in our quest for extraterrestrial life. In 1976, NASA's Viking landers conducted experiments searching for microbial life on Mars. While the results were inconclusive, they sparked a wave of interest and subsequent missions. In recent years, NASA's Curiosity rover discovered organic molecules and fluctuating methane levels in the Martian atmosphere. Methane, a potential biosignature, raises the exciting possibility of current or past microbial life on Mars. Let's travel further into the solar system to Europa, one of Jupiter's moons. Beneath its icy surface lies a vast ocean, kept warm by tidal forces. The presence of water, heat, and possibly hydrothermal vents creates a potential habitat for life. Imagine an ocean teeming with alien microorganisms or even more complex life forms swimming beneath the ice. Real-life encounters and unexplained phenomena add another layer to our story. The Roswell incident of 1947, where an unidentified flying object allegedly crashed in New Mexico, remains one of the most famous UFO cases. Witnesses reported seeing strange debris and bodies, fueling speculation and conspiracy theories. While the U.S. military later claimed it was a weather balloon, many believe it was an extraterrestrial craft. In 1961, Betty and Barney Hill reported being abducted by aliens in New Hampshire. Their detailed accounts of medical examinations and interaction with extraterrestrial beings captured public imagination and became a landmark case in UFO folklore. Are these stories evidence of alien visitations, or are they products of human psychology and cultural influence? The WOW signal, detected in 1977 by the Big Ear radio telescope, adds a scientific twist to our search. This strong, narrowband radio signal lasted 72 seconds and bore the expected hallmarks of an extraterrestrial origin. Despite extensive follow-up efforts, the signal has not been detected again, leaving it one of the most tantalizing pieces of evidence for extraterrestrial intelligence. However, the search for extraterrestrial life faces significant challenges. The vast distances between stars make direct exploration difficult with current technology. Projects like SETI, Search for Extraterrestrial Intelligence, scan the skies for radio signals or other signs of intelligent life. In 2020, the Breakthrough Listen project detected a mysterious signal from Proxima Centauri, the closest star to our solar system. Although the signal was later attributed to human interference, it highlights the importance and excitement of ongoing searches. Why are we so driven to find extraterrestrial life? Perhaps it is a desire to understand our place in the universe and to answer the fundamental question of whether we are alone. The discovery of extraterrestrial life, even in its simplest form, would profoundly impact our understanding of biology, evolution, and our own existence. But what if we do find intelligent life? How would we communicate with beings that might have completely different senses, languages, or ways of thinking? The Voyager Golden Records, launched in 1977 aboard the Voyager spacecraft, are a testament to our efforts to communicate with extraterrestrials. These records contain sounds and images from Earth, intended to convey the diversity of life and culture on our planet. However, the challenge of understanding and being understood by alien civilizations remains immense. How would humanity react to the knowledge that we are not alone? Would it unite us in a common purpose, or create new divisions and conflicts? As we continue our journey into the cosmos, let's dive deeper into some of the most compelling real-life cases and scientific investigations that keep the hope of finding extraterrestrial life alive. One of the most intriguing cases is the Rendlesham Forest incident, often referred to as Britain's Roswell. In December 1980, several U.S. Air Force personnel stationed at RAF Woodbridge in England reported seeing strange lights in the forest. Upon investigation, they encountered a metallic triangular craft emitting a bright light. The servicemen observed hieroglyphic-like symbols on the craft's surface and even experienced physical effects, such as burns and radiation exposure. Despite extensive documentation and witness testimonies, the true nature of the incident remains shrouded in mystery. Another fascinating case is the Phoenix Lights, a series of widely cited unidentified flying objects observed in the skies over Arizona and Nevada on March 13, 1997. Thousands of people reported seeing V-shaped formations of lights moving slowly and silently across the sky. The event received significant media attention and remains one of the most well-documented UFO sightings. While some explanations suggest military flares, many witnesses and researchers believe the lights were of extraterrestrial origin. In addition to these encounters, we must consider the scientific efforts to find life beyond Earth. The Kepler Space Telescope, launched by NASA in 2009, revolutionized our understanding of exoplanets, planets orbiting stars outside our solar system. Kepler discovered thousands of exoplanets, many of which are located in the habitable zone, where conditions might be right for life. One such exoplanet, Kepler 186f, is an Earth-sized planet located in the habitable zone of its star, raising the possibility of liquid water and potentially life. In recent years, the discovery of TRAPPIST-1, a star system with 7 Earth-sized planets, has further fueled excitement. 3 of these planets lie within the habitable zone, where liquid water could exist. The proximity of TRAPPIST-1, just 39 light-years away, makes it an ideal target for future studies and potentially the search for signs of life. The search for biosignatures, indicators of life, is a key focus in the exploration of exoplanets. Researchers analyze the atmospheres of distant planets for gases like oxygen, methane, and ozone, which could indicate biological activity. The James Webb Space Telescope, set to launch in 2021, promises to provide unprecedented insights into the atmospheres of exoplanets, bringing us closer to answering whether we are alone. Another intriguing aspect of the search for extraterrestrial life involves astrobiology, the study of life's potential in the universe. Scientists investigate the origins of life on Earth to understand how life might arise elsewhere. For example, the discovery of amino acids in meteorites suggests that the building blocks of life might be common in the cosmos. Experiments like the Miller-Urey experiment, which simulated early Earth conditions, showed that organic molecules necessary for life could form naturally. These findings support the hypothesis that life might emerge in diverse environments across the universe. The concept of panspermia, the idea that life could spread between planets via meteoroids, comets, and space dust, offers another tantalizing possibility. If microbial life exists on Mars, Europa, or other celestial bodies, could it have originated elsewhere and traveled across space to seed these worlds? As we ponder these possibilities, we must also consider the implications of contact with intelligent extraterrestrial civilizations. The Drake equation, formulated by astronomer Frank Drake in 1961, estimates the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. The equation takes into account factors like the rate of star formation, the fraction of stars with planetary systems, and the likelihood of life developing intelligence and technology. While the variables remain uncertain, the equation underscores the potential for numerous intelligent civilizations in our galaxy. How would humanity respond to such a discovery? The SETI protocol outlines steps to take upon detecting a signal from an extraterrestrial civilization, emphasizing the need for international cooperation and scientific verification. The United Nations Office for Outer Space Affairs, UNOOSA, has also considered the legal and ethical implications of extraterrestrial contact. Would we attempt to communicate, and if so, how? The challenges of interstellar communication are immense, given the vast distances and potential differences in language and thought processes. In our quest to find extraterrestrial life, we must remain open to all possibilities, rigorously apply scientific methods, and approach each discovery with a sense of wonder and humility. The search for life beyond Earth is not just a scientific endeavor, but a profound exploration of our place in the universe. As we continue to search the stars and study the cosmos, we may one day uncover the answers to our most profound questions. Are we alone? Or are we part of a vast, interconnected web of life that spans the universe? The journey to find out will undoubtedly shape our future, inspire generations, and forever change our understanding of life and the universe.